So, when we last left Spider-Man, he was locked out of his treehouse. He was at some distance r, and we said that the probability distribution for the distance was given by this equation where k is a constant. Okay, let's see how we could actually use this for something. So we could use this to answer questions about how likely it is that he is a certain distance from the treehouse. So one question we could ask is, what is this ratio? What is the ratio for the probability that he is at a distance 3r naught to the probability that he is at a distance 2r naught? Okay, so in other words, if we imagine this looks like about 2r naught here versus 3r naught would be this far away. So what's the probability that he's this far away versus this far away? Okay, so 3r naught versus 2r naught. What's this ratio equal to? Okay, we can do that with the probability distribution. So we just say that ratio is going to be equal to k times r to the negative 5. In this case, it's 3r naught over the probability distribution value for being at 2r naught. So we're just plugging that in for plugging in these values for r, and we can see that we can cancel the k constant. So for relative values, this constant in front is never going to be important because we can just cancel it. Okay, so now we're going to see if we can simplify this a little bit. So since they're both to the negative 5, we could just write negative 5 outside. So we've got 3r naught over 2r naught. So of course we can now cancel our r naughts, and we just have that. And a negative exponent is the same as a positive exponent, and just switching the values. Okay, so if we plug in, roughly 0.6667 to the fifth, this comes out to 0.31 approximately. So approximately equal, that's an approximation. Okay, so we can see we're only 1/10 roughly as likely to be a distance of 3r naught as we are to be a distance of 2r naught. So we're starting to see how we can use probability distributions to calculate the relative probabilities of two different situations.